Hi, this is Bill Reese again, and we're going to be taking a look at the notes that are titled Asset Pricing Prerequisites. So you might want to follow along with that as we go through this. And so we're going to mathematically define what an expected return is and what a standard deviation is. We're going to do this through some really simple examples. Okay, we're going to get into more complex examples later on, but these are really simple ones that I think will help. So I'm going to pull up the notes so I can kind of have you follow along with me as we go through this. And so hopefully you're seeing that now in your screen. And you see that we've got three different stocks, stock A, stock B, and stock C. And to make things really simple, stock A gets a 10% rate of return all the time. These are probabilities. So with a probability of 1, stock A is going to get a 10% rate of return. Stock B, there's three different things that could happen. There's a probability of 0.5 that'll get a 10% rate of return, probability of 0.25 that'll get a 0% return, probability of 0.25 that'll get a 20% return. Stock C, there's a probability of 0.1 that it'll lose 10%, go down 10% next year, probability of 0.2 that'll get a 0% return, probability of 0.4 that'll get a 10% return, probability of 0.2 that it will get a 20% return, and a probability of 0.1 that it'll get a 30% return next year. So these are the possible returns for stocks A, B, and C. Now, to calculate expected return, what we do is we're going to multiply the probability of a return by that return and sum that all up for all of them. If we take a look at the formula up above here, we say we're going to take the probability of the return, that's P sub T, times the return, that's the return for stock I at time T, and then we're going to sum that all up. So that's what that capital sigma is for there. So let's take a look at stock A. That's a really easy one here. There's a probability of 1 that it'll get a 10% rate of return. So that's what we're showing here. 1 times 10% gives it 10%. So that's the expected return for stock A. Stock B, there's a 0.25 probability that it'll get a 0% return, okay, 0% return there. And there's a 0.5 probability it'll get 10% return, 0.25 probability to get 20%. So we take 0.25 times 0% plus 0.5 times 10% plus 0.25 times 20%, add that all up. So the expected return for stock B is also 10%. And we've made this fairly simple. You can see it's symmetrical there, that on average, you could say, stock B is going to get a 10% rate of return. That is its expected return going forward. Stock C has a little bit more volatility to it than A or B do, but it's also going to end up with an expected return of 10%. So there's a 0.1 probability that stock C will go down by 10%. Okay, so that's 0.1 times negative 10%. 0.2 probability to get a 0% return, so that's 0.2 times 0%. 0.4 probability it'll get a 10% rate of return. 0.2 probability it'll get a 20% rate of return. And a 0.1 probability that it'll get a 30% rate of return. So when we do the math on that, stock C also has an expected return of 20%, or excuse me, of 10%. So we see that stock A, B, and C all have the same expected return. So if we're looking for a stock with a higher expected return, we're indifferent between the three of them. All three of them give us the exact same expected return. However, they don't all three give us the same amount of volatility, the same variance, the same standard deviation. Now, when you want to calculate the variance of a stock, and we're talking about something happening in the future, it's a little bit different than how we calculated variance when we're dealing with items that happened in the past. We don't have to worry about, do we have the entire sample size, or do we have a sample, or do we have the entire population or a sample of the population? When we're talking about the future, there's no such thing as a sample of the future or a population of the future. We're dealing with probabilities when we talk about the future. So if we scroll down here to our next page, what we're going to see is that the variance for stock A is found by saying for our one data point that we have, which was 10%, expressing it as a decimal here as 0.1, how far is that away from our expected return, which was also 1%. So we take the data point minus the expected return, we square it, and multiply that by the probability of getting that data point, which was 1. Do the math on that, and we get the variance of stock A is 0. If we scroll up for a second and take a look at the formula for variance, we're going to see what it's doing is we're taking each of these data points, that's the return, minus the expected return, which we've already calculated for all three of these stocks is 10%. We square that. So each data point, how far is it away from the expected return? Square it and multiply that by the probability of getting that data point. Okay, so let's go to stock B and figure out its variance. There was a 0.25 probability that stock B would get a 0% return. So 0 minus 10%, 0.1, you square that, multiply by 0.25. There was a 0.5 probability it would get a 10% return. So 0.1 for 10% minus the expected return of 0.1, square that, multiply by the probability of 0.5. Then there was a 0.25 probability that we would get a 20% return. So when we do the math on that, we find that the variance of stock B is equal to 0.005. The variance of A was 0. It didn't vary, so that makes sense. The variance of B is 0.005. The variance of stock C is going to be found the same way. We take the first data point was negative 10%, negative 0.1. How far is that from the expected return of 0.1? So you subtract the expected return from the data point, negative 10% minus positive 10%. You square that difference, and then you multiply by 0.1, which is the probability of getting that negative 10% return. Then you go to the next data point of 0. How far is that from the expected return? Square the distance, multiply by the probability of getting that 0 return, which is 0.2. Go to the third point, fourth point, fifth point. Fifth point, for example, fifth data point was a 30% return. Okay, how far is that from our expected return of 10%? Square that, and then multiply that by the probability of getting a 10% return. So you do the math on this, and we end up that the variance of stock C is 12%. Well, that's not 12%. It's 0.012. I'm sorry, I misread there. 0.012. So the variance of A is 0. The variance of B is 0.005. And the variance of C is 0.012. And it's pretty easy to be able to see that C varies more than B varies more than and A doesn't vary at all. Now, as we learned in our last video session, to calculate standard deviations, you simply take the square root of the variance. So the square root of 0 is 0 for stock A, so it's got both a variance of 0 and a standard deviation of 0. Stock B, if the variance was 0.005, the square root of that is going to be 0.071, which we typically express in finance as a percentage. So we say the standard deviation of stock B is 7.1%. It's not wrong to say it's 0.071, but it's just the way it's typically done. In finance, we typically, when we're talking about returns, we typically express the variance as a decimal and the standard deviation as a percentage. Then for stock C, we see that the standard deviation is going to be 11%. So again, stock C has more volatility than B. B has more volatility than A, and A doesn't have any volatility at all. Whether we're measuring volatility with variance or with standard deviation, it's the same ordering there. And sometimes it'll be more convenient for us to measure volatility with variance. Sometimes it'll be more convenient for us to measure volatility with standard deviation. So if we want to talk about risk, and we define risk as volatility, either variance or standard deviation, okay, we want to say that we're going to say that by our definition, C is the most risky and A is the least risk. In fact, A has no risk. So A has no risk. It would be a risk-free asset. B is has some risk to it. And then C is more risky than B. What we want to do now is we want to define three different types of people. people who are risk averse, people who are risk neutral, and people who are risk loving. And even though they're called risk averse, risk neutral, and risk loving, when we talk about someone being risk averse, risk neutral, or risk loving, we're not only talking about how they feel about risk, but how they feel about expected return as well. In all three cases, individuals who are risk averse, risk loving, or risk neutral, they want higher expected returns. They all want higher expected returns. However, someone who is risk averse wants a higher expected return and they want a lower standard deviation. Not one or the other, they want both. They want a higher expected return and a lower standard deviation. Someone who is risk loving wants a higher expected return and they want a higher standard deviation. Someone who is risk neutral wants a higher expected return and they don't care about standard deviation. It's not that they want a high or low, they just don't care one way or the other, whether it's a high standard deviation or whether it's a low standard deviation. Well, it's important to understand conceptually what we mean by someone being risk averse, risk loving, and risk neutral. But we're going to be making the assumption that everybody is risk averse. And while we're going to assume it right now, later on in a few more videos, we will be going into some more of the reasoning why we assume everybody is risk averse. But right now, let's just take my word for it that we're going to assume that people are risk averse, that people want higher expected returns and that they want lower standard deviations in their investments. Okay, so if we assume that everybody is risk averse, then investors will require, and we talked about this last time, a risk premium for taking on risk. They'll say, hey, if all else is equal, I want stocks with a lower amount of risk, if all else is equal. But if all else isn't equal, I also want a higher expected return. So stocks that have more risk are going to have a risk premium. Let's go back to our example, and I think we'll be able to see this here. With our example of A, B, and C, okay? If everybody wants stocks with a higher expected return and a lower standard deviation, all three of these stocks, A, B, and C, have the same expected return. So investors are indifferent between A, B, and C when it comes to expected return. They all have the same, but A has the lowest standard deviation. So if an investor is risk averse, they'll go to stock A. So if all of our risk averse investors invest in stock A, what does that do? That pushes up the price of stock A because everybody's buying it, okay? If the price goes up, the expected return of A is going to be going down as a result. Okay? You get a lower return if you have to pay a higher price for something. Now, stock C, being risky, nobody is buying it if we're all risk averse, okay, because we don't like the risk and they all have the same expected return to begin with. But what happens here is that because nobody buys C, its stock price goes down. If the stock price goes down, its expected return goes up because if you're paying a lower price for something, you're getting a higher expected return. So in equilibrium, we won't see this situation where A, B, and C all have the same expected return with different standard deviations. In equilibrium, stock A will end up having the lowest expected return because it has the least amount of risk. Stock C is going to have the highest expected return because it has the greatest amount of risk. See, investors who are risk averse will gravitate towards those investments that give them higher expected returns and less standard deviations. And they'll move away from the investments that give them lower expected returns and higher standard deviations. So what we'll end up with a situation here is where A still has the lowest standard deviation, but now it's offering a low expected return. Stock C is offering a higher standard deviation, but it has a higher expected return. So some investors will, even though they're risk averse, will go to A, and some will go to C. Remember, the definition of a risk averse investor is someone who wants a lower standard deviation and also wants a higher expected return. So if A ends up with the lowest standard deviation, but C ends up with the highest expected return, some investors will go to A and some investors will go to C. We'll see more of this later on. But for right now, it's very important to get this concept of what a risk-averse investor is. It's someone who wants a higher expected return and one's a lower standard deviation. And we're going to assume that everybody is risk averse, and we can measure standard deviation. Excuse me, we can measure volatility by standard deviation. As a reminder, okay, a risk-free rate of return is the rate of return you get from an asset that has a standard deviation of 0. And remember, we said before, there really is no asset out there with a standard deviation of 0. So we have to come up with a proxy for that risk-free asset. And we typically use short-term treasury bills, or some people even go so far as to use the 10-year treasury note. And in our class, we're going to say that the risk-free rate of return is 3%. It actually changes all the time based upon what's going on in the economy and what the Federal Reserve is doing, but we're just going to use that number, 3%. Okay, so that's going to be it for right now. When we get back next time, we're going to start talking about covariance.